So let's take a look at this problem together. It says that one end of a 1 meter long string is fixed. The other end is attached to a 2 kilogram stone. Stone is swung vertically, passing the bottom point with 4 meters per second. We want to know the tension at that point. Is about what value? Well, if we were to draw this, we're going to attach our point. We're going to have a 1 meter long string, and at the very bottom, this 2 kilogram stone is going to have a velocity of 4 meters per second. Well, I know I'm doing circular motion. So if I'm doing circular motion, I want to draw free body diagrams. So I'm going to say this is my x, that's my y. I'm going to use a traditional coordinate system. I know that I'm going to have a tension force pulling up because there's a string pulling up on this, and there's a weight force pulling down. I have a velocity. I don't have any other forces as far as I can see. There's no normal forces because it's not attached to any, or it's not being pushed on by any surface. There's no wind. Looks like I just have tension and my weight force. So I'm going to write down Newton's second law. F gives me an acceleration. My net force gives me acceleration. And in the y direction, I get that I have my tension force, positive tension force, minus a weight force. And this is going to give me ma. And my a has a very specific form. It's a centripetal acceleration. So if I were to actually write this down, this would be mv squared over r, where my r is equal to 1 meter. So I'm looking at this problem. I'm going to rearrange. I'm going to see that t is equal to m times v squared over r plus g. All right, let's move to a new part over here. My tension. Oh, so in this previous part, I had mass v squared over r and mg that moved in from the other side. So over here, make sure I can see my answers still. Over here, my tension is going to be equal to my mass, which is 2 kilograms, times v squared over r. Well, v squared is 4 meters per second squared over 1 meter plus 10 meters per second squared. So this is equal to 2 times 16 plus 10. And it has the units of newtons. So this is going to be 2 times 26 newtons, or 52 newtons. So I look over here and it looks like answer choice E is my correct answer. And I can do a quick little check on this. And the check that I'm going to do is I'm going to just calculate my weight force. My weight force in this case is going to be 20 newtons. 2 kilograms, 10 meters per second squared. So my tension force is providing an upward force, not only enough to overcome my weight force, but also enough to provide the centripetal acceleration, this circular motion. So this answer kind of makes sense to me. It's bigger than 20, which meant I could have eliminated out those 3 choices. 52 seems to be the number that I came up with.